All right. We're just about to get started, and we're now joined by the Rob Roberts and his very loud door slam.
Hey everyone, you may remember me. I came and stopped by your class maybe a month and a half ago with Sam from Nissan, and I'm sitting in on these webinars. It's too bad we didn't get to come to your school today, but we thought we would do this to make up for it. So Tom is really, really good. Feel free to ask questions, and here we go, right?
Yeah. So one thing I'd like to do is I'd like to ask everybody to kind of control their own mutes. I think I unlocked everybody. I know some of you remuted yourself, which is great. But let's talk a little bit about where you are with your project and see if there's any questions that you have off the top of your head, a particular list of things you'd like to see or do. Does anybody want to step forward?
Hey there, Tom. Can you hear me?
Yep.
Yeah, this is Seth Wilson. I wanted to see if you could introduce to us generative design. I believe you can do that in Fusion360, right?
Generative design isn't in the education version of Fusion360. However, I can log over to another account and show you generative if you're interested, but it's not included in the education version.
Oh, okay.
So that's probably why you're not finding it.
Yeah, that's probably why.
But generative is an interesting animal. For those of you who haven't heard about generative design yet, it's a way to develop using computer intelligence optional forms based on the function of a particular design. So the concept of shape optimization is in Fusion360, and it's been around for a while. That's where you develop a basic design or basic form, and then you ask it to optimize the geometry of that form based on loads, based on the engineering functions. Where generative design is different is you can start with just the elements that will be attached. So for example, if you're trying to do a frame for mounting a seat to the chassis, you would just put in the points that needed to be attached, maybe put in some obstacles. So you have a model or a zone where maybe the motors will be for moving the seat or relocating the seat. You can keep that as a keep out area. And what generative design will do is based on the loads that you input, it will give you a few different options as to what the structure of that seat base could be. And then based on that, you can explore other options and see what geometry would work best. There's a few good videos out there that are really nice to check out, but right now it is not part of Fusion360, at least not the education version.
Okay.
So sorry about that.
That's okay.
Wish I had better news. Anything regarding the type of work you've been doing so far in Fusion360 and maybe some things you've bumped into that you're trying to get around, or should we just start going through some of the tools and taking a look at some of the workflows? Professor Smith had asked me to take a look at some car seat type workflows, but I'm pretty much open to whatever you would like to do.
I'm doing more so of a hybrid dashboard.
Okay.
And I would love to look at how to do more of the sculpting to start rather than the modeling, because as I understand, you can't take it from a model to a sculpture. You have to kind of start in one avenue or another. And I'm most comfortable in starting in the modeling.
Sure.
But then it always comes out as just an extruded sketch. And so I would love to learn to add on to just what a simply extruded sketch looks like, because it's pretty simple stuff. It doesn't look that appealing when it's just a sketch pulled out.
Sure. Let me just quick take a peek and see if I have. It doesn't look like I have some of the stuff that I worked on before. Had a basic, actually kind of a dashboard concept that I've worked on before. Oh, wait. Let's see here. Pardon me a moment. I'm going to pop open another window and see if I don't have an archived project.
Yeah, it's fine.
Yeah. But kind of to your point, we can definitely take a look at some original starting out sculpt, but there are workflows as well for starting out as a solid that we should take a look at. So as you know, to your point that you're more comfortable or more used to starting out with maybe some solid modeling, sketch-based features, that sort of thing, and want to transition to the more complex design, there are some ways to augment. Mm-hmm. So let me see if I can find I know I've got probably an archived project here with my really awful sketching, so you guys can get a chuckle out of that.
He's kidding. It's good.
No. Let's see here. In the meantime, are there any other requests or items that people would like to, specific to Fusion, that they would like to see, or things that they've been trying that maybe just don't seem, maybe they're not connecting, or it feels like you're not really getting the full effect? Is there anything that's come to mind?
Hi, can you hear me? This is Ryan Smith. Yeah, so one of the things I was curious about with regards to the appearance, like the texturing and all that kind of stuff.
Okay.
So I see that you can set either a body or a face to a specific texture or material. Right. But I was wondering, is there a way to change like the geometry of their faces? Because for my model currently, the face geometry isn't exactly like how I would want the materials to look, or where I want the materials to be. So I'm just wondering if there's a way to change that.
Okay. Let me see. Are you talking about like the scale of the material, or?
Well, like, so if I wanted, say, like, material on the base of my car versus a different material on the side of my car, like the armrest or something like that, is there a way to differentiate the face? Because currently, like, the face is the same from the base to the side. Is there a way to sort of cut the face
Oh, sure. Okay, I've got you. Yeah.
Or create two different faces that I can have multiple materials?
Yeah, we can take a look at that. Yeah, let's talk about that too. So, okay, so we've got a couple things. Let me turn on a couple things. Are you able to see my Fusion session?
I can see it.
Yeah.
I would see it. I could also, we can hear a lot of clicking, so if you're not talking, can you mute yourselves?
Yeah, we'll try to keep the muting voluntary.
Yeah.
And that way we don't step on each other. All right, so let's talk a little bit about freeform workflows, and let's see how much of this I remember doing. So you can see I've got a body. These are some of my awful sketches. And what I've done, how many of you have used attached canvas or are comfortable with the concept?
I've used it.
I've used it.
Okay. Is anyone uncomfortable or not sure what attached canvas means? And if you're not, that's totally fine. We just need to make sure that we have an opportunity to show you where you go with that.
Yeah, go over that real quickly for me.
All right, great, no trouble. Let me think of something quick. I'm
like the one we did yesterday.
yeah, which one? What did I do?
The reciprocating saw is just on the.
Oh, okay, yeah. So let's talk about that. So basically, let's say you've got your wonderful sketch and you just want to make sure that you're able to use it to reference. So in Fusion 360, what you do is you bring in a canvas and you're able to orient it and scale it. So to do that, under the Insert pull down, you can use Attached Canvas, which also happens to be the top icon on Insert. Select the face that you want to orient to, and then go find the image that you have. Let me go to here. Go grab an image. We'll just grab this one for now.
Mm-hmm.
So when it comes in, the key here is to have some idea of what size you're working with. So this saw it's a certain size. You can scale it to rough it in. You can also mirror around a couple directions and rotate if you prefer. So you're free to reorient the model any way you like. You can choose whether or not the model that you're creating will display through the canvas. In some ways, this can be deselected, so as you're dragging edges around and it starts to align with your sketch, it can make it very easy to find out where that is. You can also change the opacity level. And at any time after you've placed your canvas, you can go back and modify these values. I'll click OK here to apply the canvas by simply expanding the Canvases folder, right-clicking and saying Edit Canvas. Another useful tool in this is the idea of calibrating. So you do a napkin sketch and you're trying to do the dash for a sedan. Well, obviously, unless you have really big napkins, you're not working with scale here. Mm-hmm. So you can bring in a camera picture or a scan. By selecting Calibrate, you can choose 2 points on your sketch and modify what the scale is. So while it's not hyper precise, it certainly will bring you very, very close to working with full-size data. And of course, you can import as many attached canvases as you like, so you can have a front view, top view, side view, all of the detail that you want, and be able to work with it. So from there, you're able to start developing your form. So if I come back to this model, and I'll use my timeline down at the bottom to get rid of the history that I have, so I have no bodies left in here, I can start to develop the basic shape. So working with the canvas itself, I can start to figure out how I want to approach creating this model. So perhaps I'll want to start from a sketch, perhaps I'll want to go into my freeform, my sculpt workspace, and use either like a face or a plane. So if I say that I want to start out with a face, I have to establish the initial plane for that face. And I can start roughing in what that initial shape will be. Okay, right now it's just a single face. However, I can go in and start adding edges or begin to subdivide. So I think we talked about insert edge when I was there before, where I can drop an edge in halfway through that face. We can also do another tool that's very similar, but can allow for a little more detail, which is called Insert Point, which is also on the Modify pull-down. Insert Point allows me to select points through the face, and when I click OK, it will, in this case, convert that to a curve. Edit Form, then, I'll select a face or double-click to select the entire body, and maybe just pull this out a little bit. Pull this out away from the canvas to make it a little easier to see. If I click anywhere in open space, all I'm doing is deselecting. I'm not leaving the Edit Form tool. So now I have the option of clicking or double-clicking an edge to grab all the tangent edges and starting to pull some curvature onto that form. I can then, still using Edit Form, maybe click the top here and holding the Alt key, start to drag out an additional set of faces. Maybe reorienting and using rotate to be able to see how that's moving.
And if you're on a Mac, it's which key?
It's Option on Mac, Alt on the Windows.
If anyone's following along.
Yeah. In fact, what we can do today is just kind of use this as kind of an observation time and Q&A session. And you'll be able to start making your own modifications to your designs. So from this, it's very easy to, again, just use Alt or Option to start dragging out additional faces. We want to try to keep the number of faces to a minimum that we need to be able to start roughing in our contour. The reason is when you're creating forms in Fusion 360, those forms will always try to maintain G2 continuity. So it makes editing kind of tricky when you have too much detail. So roughing in this basic shape, one of the things I want to do is to start creating kind of a concave face as I'm looking at it across here. So once again, nothing really new yet. I'll just use Insert Edge and double click this, and drop an edge in the middle. Then using Edit Form, double clicking that edge and pulling it back. So
the stream is a little bit slower than
it's a little slow. Okay,
yeah.
I'll watch the projected screen.
Hard to see the tools you're choosing.
Oh, okay.
Real quick, what is the difference between a plane and a face?
What a plane will do is automatically create an object that's subdivided. So let's use a plane to create something. So I'll go under Create and choose a plane. You still select an existing face or plane. Then you can choose to pick 2 points or define a center. Now, as soon as I click the second point to define that initial rectangle, let me zoom in here, give it a second. I can then use the manipulators to change the number of subdivided faces that are created. When you use the face tool, it just creates that single face.
Okay.
Okay. So I could have easily started out by creating a plane for that initial shape and then just edited the edges. There are just different times where you feel like you want to get a certain start and you can start beginning that way. Another option that we have is, well, I've been using primitives and then using edit form to make modifications. We also have the option of beginning by using either 3D primitives or also using sketches. So if I wanted to create the initial shape of maybe a seat pan, I can start a new edit form, and there are still our sketching tools. So if I wanted to, I can come down to tools like Fit Spline, select a sketching plane, and use just the plain old spline tool.
We're behind. There we go.
I wonder if they're getting the same amount of lag. To be able to rough in the initial profile that we want. This is also really useful on an attached canvas. And then begin under the Create tool, extruding. So this is a different type of extrude, but it bears a lot of similarity to extruding in the solid environment. Except we get the option of choosing how many faces there will be. Again, we want to keep it to the minimum necessary. We can also choose whether or not to embed symmetry based on the extrusion. So for example, I am extruding using symmetry, so it's going to either side of my sketch. I've created two faces, which will be two faces on either side of that initial sketch. And I have 5 faces running along the length of the sketch. If I take a close look, let me zoom in here and give it a second. You can say that the T-spline body that's being created deviates from the original spline. Increasing the number of faces will, of course, keep that closer, but let's be honest, what I'm just trying to do is start out with an idea and go from there. So just make note that having too many faces will add complexity to your edits and actually ultimately make it more difficult to get your final shape. So if you start out with something relatively simple, you can then switch over to edit form and start making modifications. For example, maybe building in some leg reliefs right away and putting a relief in the bottom of the seat pan. Start pulling your side edges forward and maybe even tipping them out to create your contour. So in very short order, you can start developing a far more complex shape. We can also start editing some of the curvature, selecting the endpoints of these curves and pulling more of a dish into the back. So some of the advantages of starting in a freeform model are just that flexibility to just explore. And working off of a canvas is just a good way to get some reference. Let me go ahead and delete that plane. Let's do just a little bit more tweaking on this model for now. I'm going to bring out the bottom of the console just a touch and bring out the center of the console a little.
Hey, Thomas.
Yes.
This is Professor Smith. My question is, why would you ever not use the sculpt mode and use the sketch?
As far as starting from a sketch?
Yeah, like you're doing everything right now within the you're not using the sketch mode, correct?
I'm not using solid modeling, correct. Yeah, I'm just simply working in the sculpt mode using freeform modeling at the moment.
So why would you ever not use the freeform mode?
Well, there's some times where you just, that solid geometry just works. Taking an object and just extruding it, adding some fillets. In fact, what I often recommend is not necessarily allowing every edge to remain smooth with the continuity on it in the freeform mode. Because in solid modeling, you have the opportunity to create precise fillets very easily, very quickly. There are just times where it works better. And
okay,
back from the original discussion is there are also techniques that when you start with a solid, you can do things like converting faces and then doing replace face, which I'd like to get to, which I definitely want to show. So let's run back here to the dash for a moment and talk about not having everything smooth. So now that I've got a really, really rough shape, in fact, let me go ahead and kind of flatten this out a little bit. I'm going to pre-select this top edge and look down it and see right now I have a lot of curvature running down that top edge that I don't necessarily want. I kind of want to flatten this out for a moment. So by pre-selecting it, if I go to modify and select flatten, it will already find all those points and just kind of average them out by weighting against each other with a fit. However, I can also say that I want it to be parallel to a plane. and select the XY plane, and it will bring those points parallel to that plane. So now they're pretty nicely aligned. Now, with that said, I'd like to bring out a portion that's going to be over the gauges. So I'll grab these edges, change my point of view just a little bit to make it easier to see. And I'll bring these out just a touch more for a little more overhang and maybe put a little curve to them. Now what I want to do is grab that entire top.
By double clicking.
Yep, with a double click, holding Alt or Option, start dragging out some new faces, and by making quick click and release moves, start to drag out what will be this top portion. Okay, and that looks fairly good, but I want to have a sharp transition. So these will be separate pieces. So a good way to represent that is to create more of a break, to make it look more realistic along this top edge. To do this, I'll go to the Modify pull down and select Crease. When I select these edges then, it will start to put a G0 condition. They're connected, but not touching. And then I'll probably need to use Edit Form. Let me change my point of view here.
And what is G0?
G0 is connected, but with no curvature.
Okay.
Okay. So
an angle.
Yeah. So these edges are still meeting. So I could use tools like Thicken to create a 3D body out of it. You can also use this as an opportunity where this top edge is also an opportunity. In this case, let me do it in reverse order where I'll select that edge and use the pull down to select Crease. So we'll grab all of those edges at once. And once the crease is applied, we have a sharp edge. Now, if we take this edge and go out to a solid model, once we have this enclosed, this is a perfect example of where using tools like the fillet or variable radius fillet that's built into Fusion solid modeling will give us a great deal of control, where using the G2 continuity that's just built into Fusion, we might have to go through and create a lot of extra edges close to each other to try to get that transition that we want. Where sometimes if we just want a consistent tangent, or even where if we just want a consistent rounded edge, the solid modeling tools can work a little better for us. So there's a lot of back and forth. And there's a lot of just decisions that kind of have to be made on the fly as to what the best tool to use is. And really, I can't, it might seem like a bit of a cop-out, but there's no replacement for just experimenting and just trying different things. Let's talk a little bit about using solid first. For example, let me just go out to the model workspace and just do something as simple as a box primitive. So I'm just going to create basically a three-dimensional solid model of a box. Okay, nothing fancy. Now let's talk a little bit about how to give that a little more character. So there's a couple different workflows we can use. One is to just immediately start sculpting something once we go into the sculpt workspace and start using freeform. The other thing is, if you have a more complex body than a box already in existence, we have some conversion tools. So under Utilities, there's a Convert tool. One of the options in Convert is to take a B-rep face and convert it to a T-spline body. So I'll select the top face, and I can choose how many faces in each direction. I can choose to give it, if this solid model wasn't just a nice flat planar face, You could have it follow the curvature a little more, where it would automatically start building additional edges in, or at least repositioning the edges to try to follow the curvature of your existing solid model a little more closely. Let's say you were already used to using some of the typical Inventor or SolidWorks workflows where you're doing lofts of solid models. If you're already comfortable with that workflow and you've started to create your design in that way, and now want to just give it a little additional detail or add some shapes that are just going to be too difficult to get from your loft, you can go ahead and use these curvature options. For now, I'm just going to leave this a nice flat face. One thing that I like to do is select this. I'll just double click on one of the faces and just maybe give it just a little more size, just a touch more. Because one thing you want to make sure when down the stream we use a tool called Replace Face is that the freeform body that you've created either from your model or kind of as an overlay to your solid model crosses over the edges so you don't leave it short. So now with that done, let me just make a couple of quick edits using freeform or using edit form. And while we're here, I want to point out a couple of options. Some things that we didn't really talk about previously. First, let's talk a little bit about the coordinate space. Right now, the X, Y, and Z, or the three axes, are oriented to the world's X, Y, and Z, as you can see in the view cube. However, let's say I have a particular point of view right now where I really want to make modifications based on that point of view. In the coordinate space section of the edit form dialog over on the right, I can change my coordinates to the view space. So now I'll be dragging points around as though I were reaching over and touching my screen and just sliding it by dragging my finger on the screen. The next option is selection space. So based on what I have selected, it will bias how things are. So for example, if I hold my command icon or control in Windows and start selecting different options, you'll see how it's repositioning that. And then there's local per entity, which will give it just that local. Now, since we're on a flat face, it has less effect, but one thing you can do on a curved face is it will locate that manipulator based on the normal of that curved face and at the centroid of it. So let's go back to world space for now. I'm just going to reselect that single point because I also want to point out another area in the edit form dialog. It's soft modification. What soft modification can do is try to add more localized control of your changes. So if I were to pick on this point and drag it around without soft modification, you can see that it's just grabbing a big chunk of the face and pulling it up. If I engage soft modification, I can go in and start limiting the distance. So let's say set in a certain size. You'll see that the area highlighted in red is reduced. I can also change the nature of the transition that it's trying to apply, from smooth to linear to bulge. So for example, if you think of bulge and you think of the radius or the distance from that point, it's like taking say a latex sheet and pressing on it with a golf ball, a baseball, or a basketball. It just changes the effect that you're having on the curvature. And you can also apply a different weight to the point. So that will also further control how that change is being spread around the model. These are just some elements that can start to offer you more options in detailing the changes that you want to make. Ultimately, I'll just keep this simple. I've made my change that I want. I'll finish my form, return to the model workspace, and under Modify, I'll go to Replace Face, where I'll say that I want the source face to be the top of the box and the target face to be the curved object. When I click OK, I can come over to my bodies and turn off my freeform. And now my solid model has taken on that characteristic. So of course, if we were to go through and then under modify, apply a shell, the interior of that volume then of course follows that contour. Does that help at all with the question on, oh, sorry, I'm missing some people with their hands raised here. Okay.
Oh, hi. This is Marseille Bonifay. I had a question about doing the modeling, solid modeling.
Yep.
So I was trying to work on the body of the car off of some sketches that I had, but it all kind of made it look a little choppy on some pieces and not make them look quite together especially when I tried putting the dashboard too. Like they all look like separate objects.
Okay.
Yeah. So I was trying to see if there's a way if you can put them all as one piece together. Yeah, because like whenever I had to try to change the angle and or draw a new part of the body, it just looked like it was a separate piece, like totally not with it. If that makes sense.
Okay. Yeah, it's of course tricky to always understand exactly what you're describing without seeing it. But if so you used solid modeling workflow to create the body portions?
Yeah.
Okay. Do you want to combine them together or connect them together just for the editing workflow, or just to try and give a little more continuity to the appearance?
Oh, it was just because it was just convenient at the time. So yeah, I wasn't really doing it for a specific reason. So like I already started making the body, then like I made the dashboard first, and then I put in another drawing I had of the body. Yeah, and then that's what made it look a little wonky. So like trying to make it as one piece.
Okay. Yeah, with the solid modeling, it's a little trickier to, when you create it in multiple pieces, to necessarily have it connect. However, if you have bodies in place and what you want to do is maybe add some bridging fillets, things like that. So for example, let me just model something up quick here.
Like the eyeball you did yesterday.
Oh yeah, that's
Kind of a good example, probably.
yeah. Let me show you something in solids. I'm going to be moving pretty quickly on the screen, so if you're not tracking every click I make, all I'm going to do is just click up whoop, then I made a mistake. What I want to do is have a separate body. All right, so I created these two objects. In fact, let me just use a little color instead of everything being nice and gray. Sorry. Let me make that blue and that green, just to really aggravate the colorblind people who thought they were getting away from gray. So right now, that could be like a dashboard in the car body. They were extruded or swept or lofted or evolved at different times. So I want to try and blend between the two. But if I choose press pull or press F for the fillet tool, and I want to create a fillet between these, when I select that edge, all it's going to do is fillet the wrong way. What I can do to just try and build a little more continuity is under Modify, select the Combine tool, pick a target body, and then the tool body, join them, and now when I apply a fillet, it goes the right direction. So if you have separate solids and you want to try and blend things together more easily, using Combine can really be helpful. The other thing that can be helpful is if you try and even if, here, let me back up a touch. So even if, let me create something else off to the side here. So here I'm creating another shape, and because it's off to the side and not physically connected, like your body work might not be physically connected to your dash initially, you can still tell it to join it to the other body. So initially, because there's no physical connection, it won't assume that you want to join things together. However, using the option in the bottom of the dialog, you can force it to join it to this other body, so that once you have those in place, I must have screwed it up. It's easier to start creating transitions between shapes. So for example, creating a loft between the two faces to connect things. By the way, if you're going to be doing things like this, pay attention in the upper right. There's the ability to change continuity, to apply G1 or G2, so you can create better form or better flow between parts that were created separately and bring them together. So instead of just straight edges, you can build curvature in.
So that's G1.
I can't remember if that was G1 or G2. Doesn't. Let me just edit. Sure. Yeah, that was G1. It was G2. You can also apply a weight. So you can say, I want that to be 2. So even in the solid modeling workflows, there's really good opportunity to do some really cool geometry. Okay. All right. There's also the ability to bring things to solid from freeform and maintain the freeform. So let's go back to the dash for a moment. And let's say I just want to take this to a solid model, just to be able to punch some holes in it, do some other things. Let me turn off my canvases so they're not so distracting. All right. How can you take that and make that a solid model? One way is to just thicken it. And there's 2 thicken tools inside of Fusion360. One is here in the sculpt workspace, and it can be very useful. But let me show you what the difference is. So if I go to modify and thicken, I can grab the body, tell it that I want a, we'll see if we can do minus 0.5. So it will offset the geometry to the inside. You can kind of see the preview here. Then I have the option of creating no edge, which will basically just create a second surface, for a lack of a better term, a second thin T-spline body, offset a 0.5 millimeter. If I say sharp, it will cap the ends with faces that are normal to the edges. Or if I say soft, which could be really nice for defining some, rubber shapes or shapes where a material will be stretched around the end, that can be done here as well. So let me just say soft edge, and you can see that it actually pulls all those sides in as well, which for this application isn't very desirable to me. It does make the, oops, sorry for the rapid flashy zoom that you'll be enduring here for a second. You see how it kind of messes with that. So let me undo this. What I want to do is something more along the lines of creating a big solid model out of this. But for one more step, let me finish the form, go back to the model workspace, and take a look at the other thicken tool. The other thicken tool is under Create. Don't ask me why. And here I can start selecting the different faces. And it will thicken it into a solid model. The big difference is this. If you thicken in the Sculpt workspace, what you're essentially creating is an A side and a B side that can be edited separately. Thickening in this workspace, I've got my model. It's pretty much what I like, but maybe I want to make a change. When I go back to the form and maybe bring this edge forward, we'll just make it obvious and say okay. When I return to the model workspace, the solid model will be updated to take on that shape. If I had done that thicken in the Sculpt workspace and moved that forward edge, the back edge would still be curved back. Let me undo some of these changes and undo my thicken. There we go. And now what I want to do is create a solid model. An opportunity that we have in the modeling workspace inside of Fusion 360 is to convert or is to take these models and build solids out of them. So let me start a new sketch, and I'm just going to create something very rough here. I'm going to select a plane, and all I'm going to do is just try and create an object that will turn most of this into a solid model. So let me just do some sketching. This isn't necessarily the optimum way, but let's just do this. All right. Let me bring this C around back. All right. Now what I want to do right now is extrude this, but I want to extrude it as a surface. So I'm going to go to the patch workspace and extrude my sketch till it goes through the geometry that's in front of it. Okay. So now what I have is I have my curvature, I have this new shape, and I have the original plane in the background. So what I can do is create these capping surfaces either as planes or as extrusions like I just did, or revolves, or a number of lofts. Then under the Create pull down, I can go to Boundary Fill. What Boundary Fill will allow me to do is select my XY plane, this extrusion, and this form. And because I didn't get this right, pardon me for just a moment. See this gap that I have here? This is breaking this tool from working. So let me fix that real quick. Just grab the sketch and pull it over just a little bit farther. Okay. All right, so now everything overlaps, and that's the secret to using this workflow. Now let me come back to Boundary Fill. Grab my XY plane, my surface, and my extrusion. There should be one other thing. And, sorry, this is what I get for just making stuff up. I didn't bring this forward far enough. I think that's the last problem. Try that now. Sorry. I'm trying my best to make Fusion look difficult to use. I'm succeeding at that anyway. Okay, and then that's fine. There we go. Do you see the object in green? The object in green is a volume that's defined by my extruded surface, my XY plane, and then the freeform body that I created. Now what I can do is say that I want to select a cell, and there could be multiple cells depending on how you define your shape. And then when I click OK and turn off the extra bodies, what I'm left with is a solid model that leverages all those various extruded bodies, forms, and that plane. Now I have something that I can take solid modeling tools like fillet and just apply a simple fillet to it, or Fusion360 has a couple of cool fillets. It has constant radius, chord length, and of course variable radius. So I can say on this end, I want the radius to be a little larger. So I'll start with, say, 1/10 of an inch on the left, and then with 0.35 on the right. Let's see if 0.5 will work. There. And then I can always, in the middle somewhere, pick another point and change not only where the position will be, but change what that radius will be at that point. So I can say 0.4 from there. Set the radius to 0.4 at 0.4 of the length. So you can control how that transitions. Again, let's give it something a little more interesting. Turn off object shadow. There. So that's one of the advantages of working in the solid environment, is that you have the flexibility of creating the freeform body, but now you'll be able to go through and start breaking things up into different objects. And that leads us to another question, or an opportunity to answer another question, where now I've got this kind of yellow.
Mm-hmm.
And let me draw a new sketch on the XY plane, where maybe what I want is to insert a new finish. So I'm just going to roughen a sketch here. You can see that's actually the back of the object. But in my model workspace, I'm going to, under modify, say split faces.
We're behind a little bit.
Okay. Yeah. Do that again.
This is packed.
Okay. So let me do that again. Under modify, I'll say split face. You can also split a body, but I'll say I want to split this area over, say, where a glove box might be, using this sketch. Now, to the question I think I understood that was asked before, now I can go in and drop a different finish on that face. Now let's not use that. Let's just use a regular wood, sorry.
Wood is a little special, right?
Well,
3D wood.
3D wood, yeah, you need to use the whole body. Oops, did I still grab 3D wood? No. Oh, I guess I did. Sorry, my bad. Operator error is the biggest. One of the biggest problems I have using Fusion is between the keyboard and the chair. That's usually where most of my problems come from. There we are. So now I've got this 3D wood. For those of you also trying to give a little better realism to your models, another really valuable tool to use is with a right click. Let me finish my applying the finish here, but with a right click, I can choose texture map controls. Yeah, it's going to want to pick the whole body. Let me see if I can get it to behave itself. Let's see if I can pick that face first and see if I can do texture map control of just that face. Nope. Shoot. Well, let me go back. So texture map controls allow you to change the position of a texture as it's applied You have fewer controls on the face, but let me go in here to the individual finish and apply a rotation in here. We'll just say 90 degrees. So now the grain is running the long way. We can make it more or less shiny. And also change the scale. Okay. So now I've got the grain running the long way on the model. But the really nice thing about taking this approach is if I were to turn that sketch back on, go in and make a modification to that sketch, turn that on again. Maybe change its position. When I come back over to this side, you'll see the change to the sketch is always followed. So that's a way to take your model and without having to break everything up, be able to apply unique finishes. And of course, you can apply things to different faces as well. Okay, what else have we stumbled into that's raising questions? Anything?
I've been having issues making renders, having the materials in renders look how they're supposed to. So say I will make a chair a black leather, but no matter what I do with the lighting and such, it just looks black. Same with if I choose, say, a redwood, it just looks brown in the render.
Really?
I'm not sure what else needs to be done to really make that texture pop out.
Sure. Well, let's take a look at that. So this one has, let me see what's in here. Plastics texture random. Let's make this more black. There we go. And let's grab that same wood. We'll just make this as gaudy as can be. All right, cool. So let's go to the render workspace. Followed up my interface here a little bit. Fix that. All right, so let's go to render. And there we are. So let's talk a little bit about environment and your overall lighting. So one thing that can cause frustration or cause problems is, let's take a look at how this model looks right now. It's going to pop back here in a second. So I can kind of see the texture, it's highlighted. However, this is a really common problem. If I were to make this the top instead of the front, it can obscure how that texture looks now. Because we're using environmental lighting, if your orientation of your environment isn't correct, it will give you problems. However, sometimes you can always reorient in order to create better lighting too. So let's put this back to being the front. And now I'll have better highlighting on the top. So now if I make changes to the environment, it's all going to be kind of oriented from the top. So if I change the settings, go to a different library setting, maybe use grid light, gets kind of dark, but I have the option of repositioning to get the highlights that I want. But a really common problem is having the view cube turned so that your lighting dome for your environmental lighting isn't in the right orientation. I don't know if that might be it. The other thing is go ahead and play around with some of the brightness settings. So maybe cranking this up to doubling the amount of lumens applied can help. But a really common problem I've seen and experienced myself is to not have the top of the model oriented in the right position. Any other subjects or any other things that you'd like to see, or would you like to take a look at particular editing tools or particular workflow? Are there any tools that you just go, what on earth is that supposed to do?
I was curious, I'm not sure if this is even a thing, but is there a way to allocate more computer resources to the render to make it go faster or anything like that?
Not really. Much of Fusion is multi-threaded, so the more processors, the faster it goes.
Okay.
Which type of rendering are you typically doing? Are you typically doing in Canvas, or are you doing the offline rendering? Like the render tool?
Yeah, what was I doing? Yeah, I was doing an in-canvas render.
Okay. Yeah, here's kind of my philosophy on the two different worlds of rendering, the render tool and in-canvas rendering. And the product managers for Fusion might completely disagree with me on this. But what I like to use in-canvas for is to generate either just a quick view, or more often than not, what I use it for is because I'm not an expert at rendering, because I don't always get it right as far as my scene settings and the position of the model and even what I'm looking at. What I'll use in Canvas to do is just kind of give me a preview of what the rendering will look like and to be able to make adjustments. So, for example, okay, I decide I don't want my gray background. I'll use my scene settings to change that color. And you know what? That 2000 is maybe a bit too bright. So let me start that, but let me do this in in-canvas rendering. So with in-canvas rendering running, it gives me better information than just looking at the scene settings. But once I have my scene set up, or once my in-canvas, even after 4 or 5 iterations, lets me know that that's probably going to give me the look that I want, then I'll stop the in-canvas render and go to the traditional rendering tool. So once I'm sure my scene is set up, I'll use this rendering tool because frankly, even local rendering is much faster than in-canvas rendering. So I'll go ahead and fire off a local render. Now I can change my point of view, change some textures, change some other things, and fire off another local render. And what I typically preserve cloud rendering for, and if you have a very modest computer that takes a long time to do a local rendering, you can use cloud rendering for more intermediate renderings. But typically what I use cloud rendering for is the high pixels per inch, very high resolution image that I maybe want to run off on a large format printer. Otherwise, I like to use the local render. And then I can bring back my, where's my render gallery? What is my render gallery? It's not minimized. Oh no. I'm not sure why I'm not getting it. Let me kill this.
Uh-oh.
Here, let me stop my in-canvas rendering.
Hey, will you show them how to set up views for rendering?
Oh, sure. Yeah. So Rob was just asking about views for rendering. One thing you can do is if you want to do some experimentation, or you like a particular render, but you're not quite finished with your model, so you want to make some additional changes, is take advantage of named views. You can always create a new named view just by right-clicking on the named views in the browser and giving it a new name. You can go ahead and explore and make some modifications. And it's kind of like a customized home view that you get on the view cube, but you can create as many of them as you want. Like I can say,
you want to zoom in on a detail or something.
Yep, you want to. So this is going to be the view that the Cheeto I dropped on the floor will have. This is the. So I want to showcase the floating display. So create this series of named views, and as you make changes to the texture, or as you make changes to lighting, you can still come back to those views with a simple double click. So it's a really nice, handy capability to have.
And then
for your
how
models.
about adding the views to the render queue so they can all just render out overnight while you're sleeping or whatever?
Yeah, for the cloud rendering.
Or even if you're going to do a bunch of local renders, can you queue them? Like, or they have to be from the view that's on the screen?
No, well, the only way that I'm familiar with is to launch the render, change the view, launch the render, change the view, launch the render.
Okay.
And they will run in parallel, even locally.
Wow.
They'll do 4 or 5 renderings at a time.
And then your computer will start smoking.
It's possible, especially if you have your quality settings cranked up and your resolution cranked up. Another option in scene settings that I often overlook when I show people, just kind of like today, is in scene settings, down in the lower part of the dialog, you can set your viewport aspect ratio. So if you're running a 16:9 display, but you only want a 4:3 rendering, you can use that as a way to help frame in what your rendering will look like when it's done. So this can be a very handy way as well. Another thing related to that is, for example, when I create some of the content for Autodesk Education Team, they want thumbnail views or certain course images in a specific resolution. In my render tool, I can set up specific renderings. So I can say 1280, and I can unlink and say by 1024 and generate renderings to a specific resolution. Okay. What other things have you been trying to do or working with that we can take a look at?
Hey, Tom.
Yes.
Could you quickly explain a couple terms you were using, G0, G1, and G2?
Yep. G0 is essentially where 2 faces meet at an edge, and that edge is sharp. G1 is tangent continuity, where one face, where a curve between 2 faces will just simply be worried about maintaining tangency as it goes from one edge to another. Let me show you in a solid model. It's a little easier to see. So let me place a fillet on this edge. Whoops, sorry. Let's make it a constant radius. And let me take a top view of this. Okay. So imagine G0 as that, a sharp edge between 2 faces looking at it from the side. G1 is just simply maintaining a radius that comes tangent to the faces on either side of it. G2 continuity takes the weight or the size of those faces and the angle of those faces that are adjacent to the curve that connects them and applies their weight. So it might not actually be, or it won't be, is a better way of putting it, a consistent radius all the way around that curve. But instead, the faces on either side, and like I said, their angle, their size, will influence that curvature, that transition from one face to the other. There's another level of curvature which Fusion doesn't do, which is called G3, which is what you'll find in automotive, Class A surfacing, and some really, really in-depth product design. But most people don't spend too much energy on that. It gets really hairy to try and maintain.
Gotcha. Thanks.
Oh, you're very welcome. What other items can we cover, or do you want to see examples of different things? Like I said, I'd be happy if there's a particular tool that you've been looking at and you haven't figured out yet exactly what that thing is supposed to do. Have any of you not used bridge or merge weld vertices or weld edges or those tools?
Yeah, could you show what's the difference between, say, weld edges and just combining things?
Okay, so in a freeform model, let's go back to the freeform of this. And let's create, let me just, I'm going to do a lot of rapid motion, but what I'm going to do here is I'm going to go ahead and create another plane, kind of like the one I deleted, which now it would have been really handy to have. And let me move that into position. Let's say we want to extend this dash down. Let's rotate this a little bit. Sorry, I'm going to have some rapid motion here. Be a little confusing. There we go. All right. So let me stretch this out. All right. So another workflow that can be very useful. So we want to start to define how the underside of the glove box area is going to look. So rather than trying to just drag these edges out, let's say I want it to be a little more, have a little more control over the transition. So this bottom edge curves back under to where the heater will be and such. And so there's a couple different ways to connect these together. One is called bridge and one is called, well, merge edge. The difference is bridge will create new faces to create this transition. Merge edges will, like the name says, just bring those edges together. So let's take a look at them in practice. So I'll say merge edge, and I'll grab these two edges for group 1 and these two edges for group 2. Now, one thing that's very important is that group 1 and group 2 be multiples of one another or the same number. So if you have 1 and then 2, that won't work out well. If you have 2, then 3, that won't work out well. 2 and 2, great. 2 and 4, awesome. You know, so you got to watch that. Another option in the dialog that you see is to maintain a crease when you're working with merge edge. So if I don't select that and click OK, that's what the result looks like. It will take the one set of faces and pull it up, and based again on their edge, based on their direction and curvature, merge that edge to maintain that continuity around. Let me undo that. Use merge edge again. Grab the first group and the second group, this time saying maintain creased edges, and you'll see how it just connects those two together. Does a little bit of stretching where necessary, but just bringing them together. I'll undo that again. This time, I want to use bridge. And I'll select side 1 will be these two bottom edges again. Slide 2 will be the same. One thing you want to look for is the arrows pointing generally in the same direction. And I do mean generally, because sometimes you'll have faces that are a little bit odd. But a really powerful tool that I like to use is this preview option on the dialog. And what that will give me is a preview of the faces that will be added. Okay? It will also, if it doesn't look like a good spider web, you'll sometimes see it twist. So we can flip the direction of 1 and 2. You can build and twist. You can also control the number of faces that will be added. So let's say rather than 3, let's only add 2 faces between these 2 existing bodies. And again, we have a maintain crease edges option. I'll leave that off and click OK. So now you'll see that it had the same effect as merge edge did initially, but it also inserted another set of faces, which essentially kept that bottom more or less where it was. It's a little different position, but it's just built in additional faces to make that work. Now, an editing tool let me zoom this out a little bit. An editing tool that can be very handy is the ability to do things like weld vertices. So for example, let me go ahead and just delete that one face. Okay? Uh-oh. She's a broken. But what I want, and this might be a horrible example because it's going to create something that you probably don't want, but it's okay. One of the great things about Fusion, especially in the freeform environment, is not so much being able to just create faces by adding things and inserting edges, but also the ability to just kind of break things down sometimes and rebuild them in a different way. So for example, under modify, I can select weld vertices, grab the 2 points that were corners, grab another 2 points, and bring that together in a different form. And like I said, having this individual face here isn't necessarily desirable, but just to show you how you can very quickly make some really, really radical changes using things like merge edge, bridge, or in this case, weld vertices. The same is true for crease or uncrease. So remember before I creased the bottom edge of this and creased the top edge and then applied a fillet? Well, maybe what I want to do is something a little different. Maybe I want a sharper detail over the dash, but I want a softer detail over the passenger area. For that, I can come back over to, I could have either not creased all those edges, or if I did crease them and decided later that I didn't want that, I can uncrease a few edges. And that will create a blend between the G0 and the G2 through this edge section. So you can get very detailed. You can actually exercise a whole lot of control over how things are transformed. And sometimes it's by breaking things and then rebuilding them. And sometimes it's just by taking advantage of the fact you can just change your mind. That's one of the great things about working with solid modeling, is the ability to make those changes. Now, if I finish my form and go back to my solid model, you'll see that some things are changed. Let me turn off that extra body and let me get rid of that fillet. Let me update my boundary fill. Oops, there we are. I might have gotten, yeah, I kind of broke it by having this model here, so it's not the best example. But But normally, if I wouldn't have done that boundary fill, in fact, let's go ahead and change our timeline back to before the boundary fill. There we are. That's what more it. There we are. Cool. So now you can see in the back in the model workspace how it goes from that sharp edge to that curve. And if you did want to add a regular fillet, it would still apply it, but you'll see how the preview kind of dies or drops off before it reaches all the way to the end. That's because it understands that it's already in a curvature, so it can't apply a fillet all the way to that far edge. So there's just so much flexibility there. Other tools in the freeform environment that you might have questions on. There's actually one that was added recently that's pretty amazing. So when you start getting into situations where you've kind of got corners coming together in a weird way, erase and fill is nice. We've had fill hole, which if you have an opening, fill hole will give you a few options for closing that up. But erase and fill will allow you to grab an area where you have a bunch of faces converging in a weird way, get rid of those faces and replace them with a fill. And oftentimes you'll find that creates a much nicer condition in a corner in a model. Any other questions or comments, answers, lottery numbers?
Yeah. So I know you use the flatten.
Yep.
Flatten tool to adjust like the straightness of a line on the very edge of what your form. But if you have a line going through like the middle of your form, is there a way to straighten that out if it's all like wavy and?
Sure. There's a few different ways. Let's take a look at that. So let's find a good one. Let's take this one. Okay. There's a few different things we can do. Flatten will work. So if I pre-select this and then choose flatten, it will try to curve that. However, if I use edit form, select this edge, there's a few different cool things that can happen. Let's take scaling, for example. I'll scale in one direction. You'll see how we can use scale to further add to that curvature, or we can go the opposite direction. In fact, if you type in a value of 0, it will do its very best to make that a straight line. Now, because it curves normal to how we're looking at it, it won't be perfectly straight, but it will straighten it out. So you can use scaling to either exaggerate or reduce the curvature of an edge. Does that make sense?
Yeah, it does. Thank you.
No, you're very welcome. My only reason for being here is to try and help. So if there's any question that you have or something you just want to see explored, it's completely my pleasure. I'm happy to do it.
An issue I'm running into is organizing sketches, because now later into my project I have like 100 sketches, and occasionally I want to go back to one, but there's no way to, as far as I can tell, to say create folders and such or hide them for the time being. Is there an easier way to organize those that you know of?
No, right now we don't have we don't have folders in the browser for like saying thinking of a seat, cushion sketch, frame sketch, headrest sketches, where you can do that. The best option I can offer is just simply renaming.
Okay.
That can help some. I mean, you're still having to go through, sort through, but at least it's easier than trying to remember that sketch 53 is for this.
Okay.
Hopefully that can help somewhat. The same thing is true for bodies. So if your model's in a state where it's got a lot of different forms, let me get rid of, anyway, let me hop out of finished form here. So for example, all these different bodies, what on earth, you know? So like this one, all it's doing is capping for making a solid model. So giving that a different name, or I don't really know why this one exists. So maybe I can rename and say, just ignore, you know, call this dash face. Just little things like that can make life a lot easier. There was a second person who was about to ask a question too.
Yeah. What is the difference between like the sculpting mode and the patching mode, or the patching and the what's it called?
Yeah, patch and sculpt, freeform modeling and patch. What patch is more traditional surface modeling tools. Patch is largely what is used to create features that aren't going to directly create a solid model, but can be used to construct it. So for example, this body, this capping body, is really just a surface. And all it was used for was to close off a portion of the dash in order to frame in our boundary fill. That's all it was for. So it itself is not going to be used as the geometry that will be printed or milled or anything else, but it just helps us to form it. The other thing capping can do is this. So let me just move this dashboard over to this display, excuse me. So let me create a new model. This is an exercise that Professor Smith saw at Art Academy a while ago. So let me start out with a cylinder, and I'll just do it partial. Okay, so let's say I want to create a control knob for a radio. Okay, so I'm just going to use edit form with the Alt or Option key to scale this in, to create some additional faces. And then use fill hole to cap off the top of this. Okay, now let's do a fill star. There we are. All right. So I'm not going to mess around with making a bunch of changes. If I use fill hole on the bottom of this, okay, I can switch it to maintain creased edges. Okay, another option, let's say I'm going to be doing some additional solid modeling, is to pop over to the patch workspace and either create a patch or create a construction plane that I can use to create a boundary. So in this case, I'll just use a patch, and I'll select the edge. Okay, I can enable chaining, I can create a new body. Now what I can do in patch, this is also great if you bring in surface geometry from other tools, is you have the ability to stitch, where you can grab those open bodies, select them, and once you've done that, let me go to the Inspect tool, grab my section analysis. Now I've got a solid model, just because I patched and stitched. So the patch workspace is kind of like an assist workspace. It helps you do other things. You can, of course, just make surfaces. So a combination of surfaces could be used to do a boundary fill. So let's just show another quick example of that. So if I go to my patch workspace, you'll notice that I have my sketching tools pretty much anywhere I go. Okay? So I'm going to use a little trick that I like to use in sketching, where I'm going to draw a line off to the left, restart my line and drag off to the right to be able to get a tangent arc. Still have radio buttons on my brain, so let me just drag something down here. All right, I'm going to select that line and the center line and turn them to construction geometry. Now what I want to do is revolve that profile. Let me deselect my axis. There. I'll revolve this around, and then I can use boundary fill between my revolved surface. So it's very much using a solid modeling technique and my bottom plane to create a solid model based on those bodies. Now, would it be better to use a different technique for this particular shape? Maybe just creating a solid would be better. However, if I was trying to form the bottom of this object based on this on a very complex surface of another object, what I can use is patch or convert to convert the face of that object for the bottom. And that way I'm creating a new body that matches that geometry by constructing it using the patch workspace rather than trying to fight with it in a solid workspace. Little oddball example, but patch really just kind of helps you assist with building other things. But you'll notice a lot of the tools are exactly the same as other workspaces. Hopefully that was somewhat helpful.
Yeah, it was. Thank you.
You're welcome. So if you haven't noticed, for those of you with some SolidWorks experience or Inventor experience, yeah, I think when I visited the campus previously, I talked about the idea of Fusion being a little too flexible for a commercial workspace. This last little workflow is another great example of that. For this particular model, there's about 6 different ways you could make that. You could do it using patches like I did. You could do it using simple 3D modeling practice using a different sketch, a slightly different sketch. Or you could use freeform to build that shape. So, you know, for when I'm working alone or with a small team, it's really easy to manage people's understanding of my design. Working in a large or disjointed team, it gets to be a much bigger challenge. So Fusion's awesome for these small, flexible, and quick teams. How else might I be of service to you? Oh, one thing I want to show you, just to make sure, and I think we did this in the hands-on, but I just want to remind you that when you get finished with creating your designs, and if you need to start producing them, to take advantage of those standard tools. I think we looked at, if I recall, we looked at the McMaster car library and the ability to grab screws and such out of that. The other thing, and I think we talked about this, but just as a reminder, is that ability to use hole features based on clearance. So using the proper fit for a socket head cap screw of a certain size and not having to look up all the standards. I can't recall for certain, but I just want to make sure before I go and leave you without recognizing that flexibility and that capability. As you'll see here, the diameter of the hole, the depth of the counterbore, and the diameter of the counterbore are all set based on the type of fastener that's used. What else can I do for you today?
And don't say finish your projects for you.
Professor Smith, is there anything that I haven't covered that you wanted touched on, or?
Am I live here? Can you hear me?
I'm sorry?
Can you hear me?
I'm having a hard time hearing.
First of all, are you able to hear me all right?
I can hear you a little bit, but it's very faint.
Okay, hang on.
Sorry.
Professor Smith, hello.
I think it's adjusting. That's still faint, but go ahead and say it. I'll try and listen.
Okay, there.
Oh, there you are. Wow. Nice to hear you.
Okay, sorry about that.
No trouble.
You know, I think I'd like to just see what the students are doing. You've gone over a lot of material, so let me think about it. But I'm just wondering if any of the students have anything they'd like to add to this or ask.
Yes, please.
So Ben and Dylan and Ethan, I haven't heard from, well, I've heard from Dylan, Ethan, and we heard from Marcel. Teddy's on. Seth, any of you guys we haven't heard of have any questions?
Do you know of any ways that simulation can help our design in this scenario? Just with you knowing what we're doing?
It would really be more around the hardware or mounting. So for example, even without generative design, which is very cool stuff, I think I mentioned previously that there is shape optimization. So let's say you were doing some sort of bracketry or something to, well, let's say that on this oddball dash here. So I created this dash to be floating out in space so that the display was floating. Let's say you were designing the bracketry or the hardware to hold that out in place. What you can do is roughen a shape for that, apply the loads, and have shape optimization, which is an option in the version of Fusion360 you have access to, tell you what material doesn't need to be included in your original design. What you can do with that then is take the mesh that's defined, bring it back as create it as a T-spline body. And what you might find is a little bit of inspiration to help you come up with a really unique looking shape that you know, based on the engineering requirements, will still work. But it's not just a kind of a vanilla triangular bracket or just a simple rectangle. Suddenly it's got a very functional form as well. That might be a place where simulation could help.
Has Fusion started the generative option yet?
It has, but not for, this is the first time that I'm aware of where a feature that is available to commercial customers isn't available for education.
Okay.
The problem is that right now, because of people kind of cloud rendering everything, education accounts for the vast majority of Autodesk's costs for cloud services. And I know there's some concern that turning generative design loose could get really super expensive, because right now Autodesk is already spending millions on cloud renderings for education. So, you know, just being honest here, it just creates a situation where there's just a high cost. Now, if someone really wanted to explore generative design, what they
I don't know if they know what it is.
Okay.
I don't know if it's worth mentioning or not, but
why don't we just screen share something from Autodesk really fast? Just the chair or a bracket or anything. Sure. And then Jeffrey, I can elaborate on like why generative design is not built in.
Oh, it's all good. I'm just, you brought it up, so I was just curious about it.
Yeah, I know it. And we get a lot of questions about people wanting to use generative design. Basically, the first question from every new person I meet in the education space is, how do I get generative design? And the answer is it's built into the Fusion Ultimate Edition. And the reason that it's been separated out is because, at least they've told me, that every time you click generate for a generative design, it costs Autodesk $45 in cloud computing from Amazon.
Okay.
So we can't just unleash it to the world, or we would be in big trouble.
Would they ever have the option to do generative design locally, or is it too intensive for that?
It's way too intensive. But there is some great capabilities. So let's just take a look at a couple examples here. Well, here's a video just kind of playing. So the very skeletal, the very bird bone looking structure that you see on the screen was created based on just a small amount of input, saying that there's, here, let me pause this. See if I can get the website to behave itself. Here, let me open up another option. Let's not do that then. Fine. Oh, here we are. There we go. So it will do a couple of different things. What it will do is optimize the shape based on the need. For example, the example in the center of your screen is you need to hold the handlebar and you need to attach to the steering stem. Based on the loads that you expect to exert, it will generate a series of optional shapes. The other thing, the part consolidation example on the right or at the bottom is actually a really nice example where it's showing this is a group of components that need to be assembled, or one component that can be printed. Now, generative will allow you to do additive manufacturing, so the printing side of it. It will also allow you to create components that can be machined, either using 3-axis or 5-axis. So what you'll do is create a scenario where, okay, we're going to be mounting based on this large hole on the bottom of this bracket. I'm pointing down at the gray items down at the bottom. We'll use that large hole at the bottom for mounting. We'll be mounting other objects on the right and left here. And you'll see how those points are maintained and the geometry in between is created. So the geometry in between can be created so that it could be machined using 3-axis or 5-axis. So it's really interesting stuff. It's just kind of bleeding edge. But
yeah, I guess for the students who don't know what it is, essentially, rather than designing the part, you tell it for example, if the one in the center, where it needs to hold, the bolt sizes, and then it will go ahead and determine, if you tell it the material and the load, what is the optimal structure. So there's very little design or engineering. It's all done on the cloud through the Amazon cloud. Is that a good summary?
Yeah, so the computer is helping to guide the design rather than just telling you whether or not your design will work. So simulation is largely just telling you whether or not you did a good job, and this is taking it to the level where the computer is helping to influence or guide the design process. So it's pretty, like I said, pretty leading edge concepts. They're just really starting to.
So the only other thing I want to let the students know is that I'm going to be enabling them to 3D print their designs for this Nissan competition on the Stratus machine. I guess when we output it, are there any things that we should know I think we typically export it as like an IDIS format. I'm not really sure I don't recall exactly how we do that, but we are going to try to do that to their designs.
Okay, well, let's take a look at that. The way Fusion 360 handles that is a bit different than a lot of tools. So a lot of tools will put in all sorts of capability for 3D printing. What Fusion chooses to do is you have the option. Let me just go to the 3D print tool, select my object, and what I can do is control the number of faces, the quality of the output. The other thing that I can do is, since you have a Stratasys machine, they will have an app. So you can actually use this custom option to go out and find the application for using their app. And all it does is it bridges. So rather than Fusion trying to do everything, what it does is you select the print utility you want to use. Now, if you don't want to do that, you can drop out an STL file using these mesh settings. Or if you do, it will connect to another application which can, in and of itself, have its own capabilities. So, for example, this is Autodesk Print Studio. And Print Studio will tell me, based on the machine that I have selected, whether or not my print will work. It will allow me to analyze the model, make sure it's okay.
So the Print Studio would just show up on my PC within Fusion? Or do I have to download that?
It will prompt you to install an application. So it could be Print Studio, it could be Meshmaker. Let me go back and modify this model here. I'm going to force a situation. There we go. Let me slide this up. All right. So now let me go and now that I've put this so it's up off of the table, I can tell it to add supports that will hold the model as it prints, you know, so things won't fall off or flop over. And then now this is just Print Studio itself doing this. I can have it go ahead and preview what that process would be. It will tell me it's going to take 32 cubic centimeters of material, take 3 hours based on using a Replicator 2 with PLA material. So this is what the steps are. There we go. So it's just going to build it up in this fashion. So connecting to Stratasys' proprietary software, basically where Fusion's role in the process it stops is when you click OK, and it should launch your model over into that other software and allow you to control the variables, which, being native to that piece of hardware, are probably going to be a lot more refined. But that's the process for Fusion. It's very straightforward.
Okay. I don't have any other questions.
Okay.
I think these guys just need to keep working on it, unless they do.
Sure. If I can ask you each to, I think some of you already have registered for the evaluation system. If you have, you don't need to go to the .com/register, but if you can go to education.autodesk.com, search for the course by clicking the search course and putting in this number. You'll need to enroll in it and then go ahead and then take the survey. If I could ask you to do that.
So guys, take a screenshot of this.
And then after a few seconds here, I want to switch to another screen to give you some additional resources. So you're always welcome to reach out to me or have the professor reach out to me or any of the faculty reach out to me. But there's also some great tutorials on Fusion 360 that might help you through on some things too. And of course, the help system and the forums as well. So I'll give you just a few more seconds with this. And then let me go ahead and walk through some other tools. Oops, there. So the URL on the top We'll take you to some of the built-in tutorials for Fusion360 that have some great resources, especially around industrial design. And then there's always the Autodesk Design Academy. But let me pull this one screen over. I'll give you a couple more seconds to make note of that, or just do another screen grab. And I want to show you the that Get Started page, which, like I said, is a great resource. Let me just drop that up here. So for example, under product development, no, I don't want the video. Sorry. We go to start learning. There we go. So some really nice conceptual modeling fundamentals, and then a similar course using essentially the same model but a different approach. Really nice stuff. And if you wanted to at least look through the tutorials on generative design, that'll give you a better feel as well. And like I said, right now it might not be useful, you might not be able to use it for this current course, but in your roles and where you are in your career, generative design is the sort of thing that could be very important going down the road. So understanding that it's possible to use machines to augment the design process might get you to kind of look at things a little differently and be prepared for the future.
Cool.
All right. Well, that's all I can do for you today. I do appreciate your time. I appreciate your patience, and I know it's tricky to have to log in from home and be connected, but I do appreciate the opportunity and wish you the best, and hope that this was useful.
Thank you, Tom.
All right. Thank you. I hope all of you have a great day.
Yeah, thanks so much.
You too. Thank you.
You're welcome. You're welcome. Take care.